All right, welcome to AP Calculus, Chapter 4.3, Derivatives of Inverse Trig Functions. Before we get into the actual inverse trig functions, there's a couple things I want to go over with you. The first one is very just quickly some notation. Inverse trig, arc sine, arc cosine, arc tangent. I prefer to say arc sine because when we look at the other notation, which we will see over and over and over again, inverse sine sort of looks like sine to the negative one. We're going to write it that way, but I'm going to try to remember to say arc sine all the time, just because then that reminds us, hey, this isn't to the power of -1. So let's very briefly talk about inverse functions. First of all, if I've got the function y equals x cubed, you may remember from algebra 2 that I can find the inverse function, y inverse equals the cube root of x, by reflecting across the line y equals x. And this is going to be really important for finding our derivatives, because if we do zoom in of just one part of this graph that I've drawn, and here's my inverse function, and here's my original function, and of course they are reflected across the line y equals x. And what that means is that if there is a point on this graph at A, comma B, there will be a reflected point on this graph at B, comma A. Okay, so hopefully, so far so good. Let's draw some tangent lines. The tangent line to the graph of y at x equals a, this is y prime of a. And let's look at the tangent line to the graph of the inverse function. This will be y inverse prime of b. Okay, lots of weird notation there. I've got y prime of a, the derivative of y at point A, and at the corresponding point on the inverse graph, I've got y inverse prime of b. So two tangent lines. So that's important. Now, here's what I know about these tangent lines. They are reciprocals of each other. The slopes are reciprocals. The slopes of these two tangent lines are reciprocals. And it's a function of reflecting across the line y equals x. You end up with the reciprocal slope. Now, don't get this confused with a normal line where it's opposite reciprocal. No. This one's 2, that one's got to be a half. Well, other way around. This one's 2, that one's got to be a half. This one's 10, this one's got to be a tenth. When you reflect them, your x's and y's switch. So think of it as your change in x or change in y over change in x gets flipped and becomes change in x over change in y. So if we write that mathematically, we can say that the slope of the inverse function at b is equal to the reciprocal of the slope of the original function at a. All right. So two things that we have to do. One, we take the reciprocal. Two, we switch the point to a and b. So let's do an actual numeric example using our original function, y equals x cubed. And let's say that we're going to look at the point 2, comma 8, which is in fact on my graph. 2 cubed is 8. All right. So the derivative of the original function is 3x squared. So the derivative at x equals 2 is 12. All right, so looking at my graph, if I graph y equals x cubed, there's a point 2 comma 8. And the slope of this tangent line, m equals 12. All right, now let's look at y equals the cube root of x, also known as x to the 1/3. This is the inverse function, so I'm going to notate it with the inverse function, and the derivative of the inverse function is 1/3 x to the negative 2/3, just using power rule. So if I, recognizing here that this point is 8 comma 2, the corresponding point, and it has a tangent line, I would expect that slope to be 1/12, according to my idea. So let's see what happens. Y inverse prime, or the derivative, at 8 equals 1/3 times the cube root of 8 squared. 8 squared is 64. The cube root of 64 is 4. I get 3 times 4, which is 1/12. All right. So what do you need to remember out of this? You need to jot this down. You need to remember that you need to worry about the reciprocal and switch the x and y values. That is really the big deal here when you're doing this, and this is where we tend to get confused, is that we maybe remember reciprocal, but we forget to then use the y value instead of the x value when we plug that in there. Okay, so I'm going to stop here, and when we come back, we will look at one of the inverse trig functions. Thanks for watching.